This is a presentation for our project for the Digital System Design course. Our team is called Bazinga, and it consists of 5 members. Me, Fadi Jamil, Ahmed Tariq Mansour, Minna Nader Al-Sayed, Rana Ahmed Shaker, and Aya Muhammad Yusuf. When we thought of making our project, we thought of making something that would be helpful to the society. And what can be more helpful than helping a man with a limb disability to get something? Imagine a senior living alone in his home, and he has a disability in his leg or in his hand, as he cannot hold an object, and this man needs to grab a drink or something for himself. How can he do it? So to start talking about our project in details and scientifically, we divided our project into 4 main parts. The first part is a car driven with 4 motors. The second part is a holding arm driven with a servo motor, something called like that. And the third part is we divided it into the power supply going to the hardwares and input pin assignment. Imagine this old man trying to overcome his disability and going to grab whatever object he was going to grab, a drink or anything else, and then he falls down and gets injured or something. So that was the main aim of our project, to help the society in that way. So our project, in a top view, it aims for helping anybody, so having a disability or not, to grab anything without moving even an inch from his place. Grab anything, even if it's far away, without moving from his place, only with controls and something like that. And now I would like to present you my friend Aya Muhammad Yusuf, who will talk to you about our used car in the project and how do we assign it to the project.
Hello, it's Aya, and I will explain to you the car part of our project. As you all see, this is our car. We made this car by ourselves. It consists of only parts, and we need this design from those parts. Our car consists of 4 motors, a motor for each wheel, and then we linked each 2 parallel motor with 1 input signal. That's because we don't need to move each wheel independently. We need only to move the side all together. When we were developing our design, we wanted to make sure that our car can fully move forward and rotate without any bugs. We will use this car to hold the arm and move to any place we wanted to go to. We will control this car by using the keyboard, 1 button to let the car rotate. When the car reaches our object, we will order the arm to hold it and then give the car an order to rotate and then give back to us to hold the object. And now my friend Ahmed will explain to you the arm using a servo.
Hi, I'm Ahmed Tariq Mansour. I will be explaining the main part of our project, which is the arm. Our arm is a steel arm that is connected to a servo motor. A servo motor is either opened up or closed depending on the angle. And the servo motor is connected to the Altera through 3 different connections. The first one, which is the VMS, it's a 5 volt output from the Altera. Second one is the ground, and last but not least, the signal connection. The signal controls the angle of the arm. The arm will hold at this position as long as the control signal is the same. In our project, the arm should start receiving signal when it reaches the object, and it depends on the input of the user. It will open up and close on the object, and then it will reverse the action back when it comes back to the user. Now my colleague Minna Said will follow up with the pin assignment and the power supply.
I'm Minna Said, and I will talk to you now about the power supply needed for the whole project. We have 3 elements that needs power: the car, the mechanical arm, and the buzzer. The car consists of 4 motors, and so we will need 7.5 volts to function. We added 5 batteries that each is 1.5 volts. To the mechanical arm, the servo needs around 5 volts to function, and the Altera board provides us with 5.5 volts already, so we could just connect it, the signal and the VCC to the Altera board. Also, the buzzer only needs like 3 volts, or just the voltage produced by the signal it gets from the Altera board. And now to the pin assignment. The pin according to the following diagram. Here, in the 6 pin from the right and from the left, we have the 2 power supplies. The 5 is from here, and the 3 is from here. And we assign the 6 bits needed for the car to function at the very beginning of the pins. Here we have the 2 enables, and then the four combinations that makes the car works. And here is a signal for the servo motor. Right next to it is the VCC and the ground for the motor. And the signal of the buzzer is assigned right in front of the servo because they work at the same time. And the buzzer will only need a ground from the 3 volt back here. Thank you. I will leave you with my friend Rana, who will introduce you to the practical implication of the project and will show you the controls.
Hi, I'm Rana Shaker. Now I'll show you the practical implication of our project and the keys, how we control it, the pin assignment, as Mena said before. So we assign these keys. This one is to control the arm, which was controlled by the servo motor. And when it opens, it causes a buzz. This buzz acts as a sensor that it opened and closed. And our aim, like Freddy said before, was to help senior citizens to grab anything, or people with disabilities in general, if they can't move an arm or a leg or whatever. So let's imagine that this is our senior man and he wants to drink a juice and he cannot move. So what he will do, he will control our project using the Altera board and with these keys. So now I'll show you the practical implication and example. And now the juice was arrived safely to the senior citizen and he can drink it now. So thank you so much. That was our project and our team Bazinga. Thank you. And now it grabbed the juice to this senior man